Hi and welcome to my Year 12 video on the dehydration of alcohols. So have a think, first of all, what product do we get when we dehydrate an alcohol? The answer is an alkene. We actually did a practical on this when we formed alkenes and we're testing the alkenes that we produce. And if you remember, we had this kind of setup, so similar to a cracking setup at GCSE, where you might have had collection underwater of the gaseous product, which would come out of a Bunsen valve at the end. And if you think about what we had in here, so this was our mineral wool that contains our alcohol that we were dehydrating, and we were heating a catalyst in here. That catalyst was aluminium oxide. You had the small spheres of aluminium oxide in there. So aluminium oxide is one of the reagents that you can use to dehydrate an alkene, and you can also use pumice. Both of those need to be heated strongly before the alcohol vapour is passed over. So remember, if you didn't do that, what would happen is the alcohol would just evaporate or vaporise and then go into the cold tube without reacting, i.e. it would just distill. So we want to make sure that the catalyst is really hot before we do that. So we heat that strongly, and enough heat will just enough energy will just transfer across to vaporise some of that alcohol. And once this is nice and hot, as it passes over, there will be enough energy to overcome the activation energy and to break bonds, because we're going to have to break actual covalent bonds in order to dehydrate the molecule. So the dehydration equations, quite simply, we want to remove the water. So there's nothing else on the left-hand side, and that will dehydrate to form the appropriate alkene. So in this case, you're going to form, let's put the CH2 on the left, so you're bonding through the carbons. You're going to form ethene there with the loss of water. Now, if you had to think about the type of reaction, so way back when I introduced you to that word type, we were looking at things like electrophilic addition, for example, as a type of reaction. Clearly this isn't an addition reaction. The reaction type that this is an elimination reaction. We are getting rid of something from our starting material. Now, the key thing, I'm just going to look at a specific example and make you think just a little bit. So I'm going to draw out an alcohol. Notice I'm always trying to join through the carbons. And there's my alcohol group. Now, the point is, this molecule will not dehydrate. So not every alcohol can dehydrate. Now, some of you might look at that very quickly and say, oh, does that mean that tertiary alcohols don't dehydrate? But look carefully, that is not tertiary. This is a carbon with our OH on it, and it has two hydrogens and one highly branched R chain. So it's just got one R group, so it's actually a primary alcohol. There are no rules as to which alcohols, no type, primary, do, don't, there's none of that. It's just a case of having to keep an eye out to see that what you need is your alcohol group, OH, needs to have a hydrogen atom on the adjacent carbon to the C containing the OH. So this is the adjacent carbon, And this doesn't have a hydrogen on it. It's got C's at every position because it's highly branched. So what would normally happen, if I change one of those and make that slightly less branched, put a hydrogen on, what you're doing is you're actually eliminating that OH with this H, with an adjacent hydrogen on an adjacent carbon atom to the COH, is coming off, and that is what's then allowing the double bond to come in between those two carbon atoms, because of course these two sets of atoms will have gone and we'll be left with a double bond. So be left with, if you had that as the original alcohol, then your product would then be that. So it's actually methyl propene there. So not every single alcohol will dehydrate. So I'm going to finish this off by posing you a question. So here we have our alcohol that I'm going to use. So first question is, what is it? All of these are going to be hydrogen, so have a think. What is that? So the answer, of course, is butan-2-ol. And I'm going to ask you to pause the video and work out what you get when you dehydrate butan-2-ol. Right, if we look at that, some of you may well have written down just one product. But what you have to be careful of is this. The OH has two adjacent carbons to the one that the OH is attached to. This one here, if I were to lose the OH with that hydrogen, I would form the product of butanene. So I would put my double bond in there and therefore form butanene. However, I also have the possibility of taking away the H and OH from this side of the OH and forming a double bond in here, which of course would form but-2-ene. So there are sometimes more than one possible dehydration product, depending on what is adjacent. So you could imagine, for example, you could imagine having another different length carbon chain up here with H's, and that potentially could create another possible product from that, if it happens to be different in chain length. I think it'd be highly, much more demanding question. I don't think I've seen one like that before, but it is possible. This is definitely something that they would expect you to be able to handle. In the same way that when you have butanene and you are reacting it with steam and the conditions to add the H2O across, that there are potentially two products there. Here, there are potentially two or more, maybe even, products dependent on looking at the original alcohol. Thank you for listening.